Today we will see the case control studies. These studies are done retrospectively, so looking into the past rather than having an hypothesis and testing it in the future. So the prospective approach to the design of some vaccine would be the following. So you recruit unvaccinated people, then you randomly assign them to vaccinated or not, follow both groups for many years to compare the incidence of cholera in both groups. This is somehow what we do with animals. So you take some mice, you assign them to treatment or control, and then you follow them. So you set up the hypothesis, and then you look into the future to see whether your hypothesis was true or not. But this study would require many years and would withhold the vaccine from many people if this vaccine is useful. So the retrospective approach is called the case control. So this case control, you pick cases and controls and annotate whether they had been vaccinated or not. So you had an old vaccine, you think it was useful, and then you compare two groups of patients that have had cholera and people that didn't have cholera, and then you compare the sizes of these two groups. So you may end up with a table something like this. So you have cases, those with cholera, and 10 of them were vaccinated and 33 were unvaccinated. And in the controls, 94, so these controls didn't have cholera, and 94 of them were vaccinated and 78 were not vaccinated. So you can still apply the Fisher's exact test. The null hypothesis is that the two variables, vaccination and disease, are independent, and then the p-value is relatively small, so 10 to the minus 4. So you reject the null hypothesis that the two variables are independent. So there must be some relationship between vaccination and getting the disease. So if you compute a p-value, if you make a test that is two-sided, so that means that you don't know whether the vaccination will result in a higher or lower incidence of cholera in the vaccinated group. Otherwise, if you are only interested in detecting vaccines that reduce the level of reduce the incidence, then you should do a one-sided test. Okay, so you may note that the number of controls is chosen by the researchers. So you can put more or less controls into your study. So that makes that computing the relative risk is an analysis by rows, is somehow not so much sensitive. It doesn't make sense actually, because the number of controls, you can arbitrarily put more or less controls into the groups, and then you are artificially touching the relative risk. So the relative risk in this case would be an analysis by rows, would consist of you take all the rows, so all the people in a row, so this would be 10 plus 94, and then the risk of getting the cholera in this group would be 10 over 104. So that is 9%. In the vaccinated group, it is the same. So 33 divided by the sum of 33 plus 78. And the problem is that since you can put more or less controls here, you can artificially change these ratios. And then you compute the risk ratio, the relative risk as the ratio between these two probabilities, and it doesn't make sense when in case control studies. It doesn't make sense to analyze things by rows or things in which the denominator is artificially chosen by the researcher. So if now we analyze it by columns, you can still control the number of you can choose the number of controls, but what you cannot choose is whether they have been vaccinated or not. So now the denominator is not affected by your choice. So now, if you analyze by columns, then it would be 10 over 33. So now we don't divide by the sum of the two, but just by the ratio between vaccinated cases that have been vaccinated, cases that have not been vaccinated, and the same for controls. Now you can compute the odds ratio. That is the ratio between these two numbers, that is 0.25. So that means this ratio is called the odds ratio, and it means that vaccinated people is 25% as likely to get cholera as unvaccinated people. So if there is no relationship between the vaccine and the disease, then this ratio, odds ratio, should be around 1. And the 95% confidence interval for this odds ratio, there are some formulas to calculate that we will not see, is somewhere between 0.12 and 0.54. So this confidence interval doesn't include 1, so you would reject the hypothesis that there is no relationship between being vaccinated and getting cholera. Then the effectiveness of the disease is defined as the 1 minus the odds ratio, so in this case it is 75%, and the confidence interval is just this one, 1 minus this confidence interval. So the confidence interval for the effectiveness goes from 46 to 88%. There are many problems with case control studies, and that is why in basic research normally with animals you never do looking into the past, but you put an hypothesis and then you look into the future. And let's see some of them. So in the cholera samples, the researchers picked the controls visiting homes near the area of a patient, but the controls were picked because they were of the same gender and age as the subject. So they could not determine whether the vaccine was more or less effective depending on the gender and age, because they are all made with same gender and age. Then the patient knew they had cholera, and they may remember their vaccination more vividly than controls. So they are rather surprised that after being vaccinated, still they have cholera. So they have this remembering very, very vividly, while the other ones, they don't really remind whether they were vaccinated or not. And also the interviewers knew who had cholera and who did not. So they may inadvertently pose the questions in different ways and leading to different responses on vaccination. The patients may want to help the researchers because they have suffered a bad disease, so they want to help, but the controls, they don't care so much and they just want to finish the interview. So the quality of the two kind of responses may be different, and patients were chosen because they attended the cholera treatment center. So patients with milder symptoms, they did not seek medical attention. So you are biasing your sample towards people who had cholera in a very severe way. And controls were at home when the interviewer came, so the study was biased towards people who stay at home more often. Then another way to validate a case control study is to perform a parallel case control study on something that you know that is unrelated, but following the same procedure as you have had for your primary study, and then this second study will serve as a control for the analysis itself. So they studied whether there was an association between cholera vaccination and other patients with bloody diarrhea not caused by cholera. And the controls were chosen in the same way as in the first cholera study, and they had the same kind of bias, and the odds ratio in this case was 0.64, and the 95 confidence interval now included 1. So that means that we cannot reject the hypothesis that both variables, so being vaccinated against cholera and having a bloody diarrhea not caused by cholera, they are totally independent. And in general, it is said that you should be skeptical of odds ratios that are in the range between 1/3 and 3, or even 1/4 and 4. So unless there is a very strong evidence that two variables are correlated, or they are not independent, then you should be skeptical of all those odds ratio. And case control studies can be trusted if they can be repeated and they make biological sense. Otherwise, all these biases that we saw here, they may be affecting your calculation of the odds ratio. There is a common mistake that is confusing the relative risk with the odds ratio. So there is a relationship between the two, a one-to-one relationship, but the relationship includes the prevalence of the disease. So that is the fraction of the control group that has the disease. And then there is another mistake that is entering normalized data. Number of cases per 1,000, number of cases per 100,000 instead of the actual counts. Or there is another mistake that is trying to compute an odds ratio when one of the 4 values involved in the odds ratio is 0. So if any one of these 4 numbers is 0, then the odds ratio is not well defined. So that is all for the case control studies, and see you next time.